Hello, this is Measurement Relationships 8.1 Pythagorean Theorem. Now, the Pythagorean Theorem, in its very basic form, is when you have a right triangle, the square of the length of a hypotenuse is equal to the sum of the squares of the lengths of the two shorter sides. So if I have my right angled triangle, so that I know right here, this is a right angle, so 90 degrees. I know that my two shorter sides, I'm going to call them A and B, and I sum their squares, so I square them, multiply them by themselves, it's going to equal the sum of the squares of my hypotenuse, which is my side C. So this length right here, this is my hypotenuse. And it's basically the diagonal that attaches the two shorter sides, which are at the right angle. So, in many respects, we see this as a squared plus b squared equals c squared. So this is a relationship that applies only to right-angled triangles. And it was thought up or kind of theorized by Pythagoras, who was a Greek philosopher and mathematician. He lived about 2,500 years ago, give or take a couple decades. So, and he was doing this as a way to kind of think about the universe, and he came up with this relationship which he thought was very, very special. So, when we take a look at the squares of the sides, like so, we know that the length of my A side here, my B side here, and C side, well, I have to use another color for this one. See here, when I square them, they're going to be equal. So let's take a concrete example, and this is one of the more famous examples. Let's say I instead make my A side, let's make this 4, my B side, let's make this 3, and we'll see if we can figure out what my C side should equal. So when I square it, I'm essentially finding the area of the square that is created when I take my side. So I have 4 and 4 and 4 here, and then I have 3, 3, and 3. So this square has a total of 16, whatever units. And my yellow square will be equal to 9. This C kind of blue square here, it's going to be equal to the total. So it's going to be equal to 16 plus 9, which equals 25. So that whole square, its area is 25. But the length of C will be equal to the square root of that. So I take the square root of both sides. Square root of C squared is C. Square root of 25 equals 5. So that I know C is equal to 5, and that's the length of my hypotenuse. So this is the famous 3, 4, 5 triangle because I have all three of my lengths are integers or whole numbers. So let's take a look at another example. So I have my right angle triangle here, and let's say I have, I don't know, 6 here, and I'll have 7 here. And I'm trying to find out what my C length is. So I don't know. And it's not going to be 8 because the 3, 4, 5, that's really the only case for that. But I have 6 and I have 7. I want to find out what C is. So I'm going to apply my Pythagorean theorem. I know that this is my A side, this is my B side. So I'm going to have A squared plus B squared, and it will equal to the C squared. So the C squared length. I plug in 6 for my A, 7 squared, C squared. 6 times 6 is 36. 7 times 7 is 49. Use a calculator if you have one. And those will be equal to C squared. So I add up my 36 and 49. So I'm going to get 5 and 8 is equal to C squared. And then to get my value for C, I merely square root both sides. So I take the square root of 85 for my trusty calculator. So 85 square root, and I get the value of roughly 9.22 equal to C. So a lot of times with these when we square root, we're going to get these kind of odd decimal values, and we want to maintain significant figures. So I got 9.22, and I really only started off with 2 significant figures, so I'm just going to have to round that again to 9.2. Don't worry about it if you got the exact right amount of significant figures, but just try to keep a consistent number of like decimal places or actual numbers, and that should get us a fairly correct answer. So here 9.2. All right. So now we're just looking at trying to find C. What happens if I'm given C, but not one of the other A or B's? So let's look at that example. So I'm just going to erase this here. And let's say we start off with, I don't know what A is, but I know that this is, say, like 11, and let's say that this is 16. So now I want to find out what A is. I'm still going to use my Pythagorean theorem, A squared plus B squared equals C squared, and I'm still going to plug in the numbers of what I know. So, don't know what A is, but I know that B is 11 squared, and C is 16 squared. So, I still have A squared plus 11 squared, which is, I believe, 121. And I'll have 16 squared, which is 256. So here, just like in algebra, I'm going to collect my like terms. So I'm going to take my 121 here, move it over, and change the sign. So I'm left with A squared equal to 256, subtract 121. So A squared is equal to 135. Again, square root both sides. Find out A. And A, oh, not squared now. A is equal to 11.62. So, figured out my A. So, those are really the only 2 types of cases that we're going to see with our Pythagorean theorem. Either we're going to know C and try to figure out one of the other sides, or we're going to know A and B and we have to figure out C.